Hello, we're on 8.04 geometry today, talking about partitioning a directed line segment. Lots of fun. Okay, hopefully it's a little clearer than last time. Okay, so first of all, there is a formula that we're going to talk about, but before we get into that, let's just talk about how we can break up a segment into different ratios. So question 1, determine the ratio of the directed line segment. So what a directed line segment is it's a line segment that is going in a direction. So it's like a ray where it's pointed in one direction. You're going from one point towards another. So segment AB with an initial point at A. When it is partitioned, which just means broken up into parts by point P, if the points I'm going to make indicated on the diagrams are equally spaced. All right, so A. Let's take a segment. So segment AB, we'll divide it up. So we're going to assume these are equally spaced. 1, 2, 3, 4, 5. I made it a little long. Let's take this off. So this is A, and this is point B, and this is P. All right, so looking at this segment, determine the ratio of the directed line segment from point A and when P is partitioning this segment. So we've broken this up into 1, 2, 3, 4, 5 different parts. So to figure out how it's partitioned, we're going to count how many spots before P. So that's 1, 2, 3. And after P is 2. So the ratio here, ratio, for this one would be a ratio of 3 to 2 because we're going from A to P and then P to B. So we have 3 spaces and then 2 spaces. So we're going to call it a K value. And K is going to be in our formula. We're going to call it our distance ratio. So the distance ratio would be, to find it, you're going to take the first number in your ratio, which is a 3, so from your initial point, how far it is, out of the total. So in total, we have 1, 2, 3, 4, 5 spaces. So what that's saying is point P is 3/5 of this segment, along the segment towards B. So from A, you would go 3/5 of the way, stop at P, and then you would continue your other 2/5 of the way after that. So P is 3/5 of the way along this segment if you start at point A. All right, let's look at B. So B, I'll give you another segment. So we've got 1, 2, 3, 4. So this is B, P, and A. All right, so take a moment here and find me the ratio. Again, if A is your initial point, and we want to find the ratio for P, so where P is located along the segment, and then find the distance ratio K as well. So how far along as a fraction point P is from A. All right, so here we can count up. We have 1, 2, 3, 4 spaces before P and 1 after. So the ratio for P would be a ratio of 4 to 1 when it's partitioned. The distance ratio, so how far is it from A? So I notice here that it's more than halfway, right? Because we have 5 in total spaces and we've gone 4 of the 5. So I know that it's more than halfway. So it's going to be 4 out of how many spaces do we have in total is 5. So, and again, these are all equally spaced, we're assuming. So we've gone 4/5 of the way along the segment to get to point P from point A. And that's what K tells us. Again, to get K, you're just taking the first number here, which is a 4, divided by the entire, you'd add these two together. 4 plus 1 gives you 5. Here we took 3 is our numerator. 3 plus 2 is 5. All right, now let's take a look at our formula. So our formula for a partitioned point is an ordered pair. So you're going to take the x sub 1, so the x coordinate, plus k, which is that distance ratio, times x sub 2 minus x sub 1. So think about it as you're finding the distance here. You're taking the second x value minus the first x value. And then your distance ratio is how far along that segment you want to go. And then the y values will be the same. So y sub 1 plus k times y sub 2 minus y sub 1. And that's going to be your ordered pair. So a couple things about this formula. So point P, which this is a partition point P lies on a directed segment K amount from the initial point, which is x sub 1, y sub 1. And the segment will terminate at the point x sub 2, y sub 2. Terminates at, so I said before it's like a ray in the fact that it goes in a certain direction, but it's a segment in that it has a beginning point and an ending point. So it starts at x sub 1, y sub 1 and ends at x sub 2, y sub 2. And again, your distance ratio, which we're calling K, you would take your first number of the ratio, first digit of the ratio, divided by the sum of both parts. So, for example, if we're in a ratio of 3 to 1, your K value, you would be 3 out of 4, since the total is 4 parts. So again, up here, we'd go 3 to 2, so it's 3 out of 5. Here, we go 3 to 1, so it's 3 out of 4 that you went. So that's really important. This formula, this partition point formula, you need to memorize. All right, so using that formula, we're going to do some other another problem, but first we're still going to kind of get used to this partitioning a segment. So given segment PQ and point R lies on segment PQ such that R lies 7/9 of the length of segment PQ from point P. All right, so first thing, let's just do a sketch. So we're going to take a segment. We know we want it to start at point P, and we want R to be 7/9 of the distance. So that means I'm going to have divided up into 9 parts, and R is going to be the 7th part there. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's going to be our Q. Connect these. So 1, 2, 3, 4, 5, 6, 7 right here is your R. So first, one thing that you'd want to look at here is R closer to point P or closer to Q? Well, R is closer to Q. And how do you know that? Well, I know because there's 9 spaces here, and we're 7 of them, which is more than halfway. So R is closer to Q because it's more than halfway from P. So just things you want to start to think about as you look at them. All right, now let's take a look at some ratios. So I want you guys to, I'm going to write down a few different ratios that I want you to find, and I'm going to have you pause the video and write down what those ratios will be. Q, and let's do one more. Let's do RQ to PR. Okay, so pause the video here and go ahead using this problem, this segment PRQ right here, find the ratios for each of these 4. All right, so PR would be 7 and PQ is 9, so that would be in a ratio of 7/9. RQ is 2 and PQ is 9, so that'd be a ratio of 2/9. PR is 7, RQ is 2, that would be a ratio of 7/2. And RQ to PR, RQ is 2 and PR is 7, so it'd be a ratio of 2/7. Next, let's assign some coordinates. So given that P is 0, 0, and Q is 9/18, find the coordinates of R so that R is 7/9 of the distance from point P. All right, so here, let's talk about, it's the same segment. So you've got P, which is 0, 0, Q, which is 9/18, and R here is more than halfway. We're looking for those coordinates. So let's use our formula. So our formula is right here. So you can see that at the same time. All right, so I want to take I'm going to split it into 2 separate equations, but you are welcome to write it just like this as well. So to find my x sub r, let's call it, and I'm calling it x sub r because I want it to be the coordinates, the x coordinate of point R. I'm going to take x sub 1. So I'm going to label these as x1, y1. And it is important here, you can't just call either of them x sub 1 and x sub 2. The initial point has to be your x sub 1. So our initial point is 0, 0. So we're going to take, I'll write out this formula here, x sub 1 plus k x sub 2 minus x sub 1. And then our y sub r is y sub 1 plus k times y sub 2 minus y sub 1. All right, then I don't need that there. So now you guys have the formula written out on your papers to see, in case you also had it on a separate sheet. So now we're going to take our first coordinate, which is 0. K was given as 7/9. So you really want to recognize, am I given a ratio or am I given a fractional distance? If I'm given a ratio, then I need to rewrite it as a fraction to put it in for K. If I'm given the fraction, I can leave it as is. So 7/9 and then 9 minus 0 equals my x coordinate for r. My y coordinate is going to be 0 plus 7/9 and then 18 minus 0. And now it's just simplifying. So you can use your calculator. You should be able to do it without, especially this one. 9 minus 0 is 9, and I know 7 over 9 times 9 is going to give me 7. If you need to write more of that out, you can. And then here, y sub r, 0 plus, this is 18 minus 0 is just 18. 9 goes into 18 twice, and 7 times 2 is 14. So our final answer for point R would be the coordinate 7, 14. All right, and then one other part that we'll do for this same problem, we'll call this D, is given that P is 2, -3, and R is 16, 18. Find the coordinates of Q. So it's still 7/9 of the distance. Find the coordinates of Q if it is 7/9 from P. All right, so now we have a little bit different situation. P is 2, -3, and Q is what we're looking for, so x sub 2, y sub 2, and R is 16, 18, which is right here. Hopefully you can see that. So I'm just labeling my coordinates there. So I'm going to, again, use my formulas that I used before. So I'm going to take x sub r is equal to my x1 plus the fractional distance that I went along the segment times the length of the segment along my x's. So x sub 2 minus x sub 1. So think also like your slope formula, rise over run. So this is your fractional distance of the run of how far you're going. Y sub r is equal to y sub 1 plus the distance, the fractional distance of how far I went along my y's. So now when I substitute in for r, that's going to be my x sub r, y sub r. P is still my x sub 1, y sub 1. So I'm going to substitute in. So x sub r is 16, x sub 1 is 2, k is still 7/9. I don't know x sub 2, and I know x sub 1 is 2. Now I want to solve this. So to solve it, I'm going to first subtract over my 2, and I get 14 equals 7/9 times x sub 2 minus 2. And then I would probably at this point get rid of my 7/9 fraction to isolate this x sub 2 minus 2. So to get rid of 7/9, I would multiply by the reciprocal of 9/7, which means I need to multiply this side by 9 over 7. 7 goes into 14 twice. 9 times 2 is 18. Here my 7s and 9s cancel. And then lastly, I would add over my 2 to get x sub 2 equals 20. All right, now let's do the same thing for the y side. So pause the video and do the same thing for your y's. All right, so you should have substituted in. Here, I'll just show you that part. So y sub r equals your y1 here should have been -3 plus 7/9. My y2, I don't know, minus -3, which would become +3. So again, actually, y sub r we do know. Our y sub r is 18. So now you would add over your 3, multiply again by your 9/7, subtract your 3, and your final answer for y sub 2 should be 24. So Q has the coordinates 20, 24. So that's the other endpoint as opposed to finding the partitioned point P. Okay, let's do another one. Actually, I'm going to grab some graph paper. All right, so this one is going to be number 3. So I grabbed my graph paper. I drew out some axes here. And number 3 says, given points, I guess I'll write 3 down here. Given, you can't see that, given points A, which is -8, -8, and B, which is 2, 7, find point P so that it divides segment AB into a ratio of 2:3. All right, so what I want to do here is I want to do this both graphically and algebraically. So one thing to note here, if we're going to do it graphically, it only works graphically if you're not going to have, if your answer is not a decimal. So this is really a check or a backup. But I think it's important to see it graphically as well. All right, so the first step to doing it graphically is you're going to find the slope. So I'm going to graph my points first. So I'm going to plot them up here. So I'm going to do the graph up here. So -8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. That's A. And B is 2, 7. 1, 2, 3, 4, 5, 6, 7. I feel like my ruler is like scissors when you're wrapping Christmas gifts. They always just disappear. Segment AB. And I want to find the slope. So we can do it using change in y over change in x. You can count up and over for your rise over run if you would like. So since we're doing it graphically, why don't I just count? So I'm going to count how many boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So from here to here is 15 boxes. I went up, so positive 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes for my run. So the slope is change in y over change in x, or rise over run. So that's 15 over 10. And we can reduce that to be 3 over 2. So now we're going to divide the segment using that slope. Into, and here we can tell we're dividing it into ratio of 2:3. Let's actually start doing that and see how many pieces it divides into. So we're going to go up 3 over 2 for each one. So 1, 2, 3 over 2. Up 3 over 2. Up 3 over 2. Up 3. Up 1, 2, 3 over 2. And up 1, 2, 3 over 2. So we've now taken this segment and made it into 1, 2, 3, 4, 5 equal parts. So we divided the segment using slope. And we made 5 equal parts by doing that. So now, if I want to find a point that divides puts the directed segment into a ratio of 2 parts to 3 parts, I need to find which point is 2 away out of the 5 from point A. So an A here I'm giving you is your initial point. And you know that because it's listed first as well. So we're going to go 2 away, which is right here from point A, and that's going to be our P. So the coordinates of P are 1, 2, 3, 4, -4, down 2. So P would be -4, -2. So doing it graphically, you just really need to be able to find the slope and be able to divide your segment into 5 equal parts. Since it's in a ratio of 2 to 3, we want it to be in 5 equal parts. All right, now let's talk about how to do it algebraically, which is just going to be using that formula we used before. So if you want to keep it in as using 2 parts, you can. This time I'll show you how to do it when it's together. So again, let's write out our formula. And again, you want to have this memorized. So see if you can pause the video and see if you can write it out on your own. Okay, so now we're going to just substitute in. So I'll do the x coordinate with you, and you can do the y coordinate on your own. So when I go up here, thought I had a blue pen. Here's my A, that's going to be my x1, y1, and B is going to be my x sub 2, y sub 2. So now x sub 1 is -8. So if my ratio is 2 to 3, that means that my K is going to be 2/5. So this is your partition ratio, how it's the ratio it's partitioned into. Your distance ratio, so how far the point is, will be 2 out of 5 along that segment. So point P should be 2/5 of the way from point A. So now I have -8 plus 2/5 times x sub 2, which is 2, minus -8 here. And comma, now I want you to pause the video and do the y coordinate. All right, so you guys should have had your y sub 1 is -8 plus 2/5. Y sub 2 is 7 plus 8. And now it's simplifying. If you would like, you could even put that right into your calculator, or you can simplify this to be 8 plus 2 is 10. So we've got -8 plus 2/5 times 10. 5 goes into 10 twice. -8 plus 4 is -4. And then go ahead and simplify the other side. So there you would have your 15. 5 goes into 15 3 times. 3 times 2 is 6. And then -8 plus 6 is -2 for point P. So that's the work you would want to show algebraically. Okay, number 4. Find point M on the directed segment from A, which is -2, 0, to P, which is 5, 8. That divides it in the ratio of 1 to 3. So this is our partition ratio. That's not our K value. Okay, we need the fractional distance. So they've given us here that A is -2, 0, and P is 5, 8. we want to find point M so that it divides it in a ratio of 1 to 3. So if this is M, we would want this to be like 1x and this to be 3x. So what would your K value be if you're in a ratio of 1 to 3? Pause the video, write it down. All right, your distance ratio here, your fractional distance should be 1 over 4. So it's 1 out of 3 plus 1 is 4 parts, which means that M, you want to be 1/4 the distance from point A. So this is our fractional distance is 1/4. All right, that's just kind of figuring out the K and all that. Now let's go ahead and find the coordinates. So using your formula, and you can either set it up like we did in the last one where we wrote it as an ordered pair, or in the first ones where we separated it into 2 separate equations. Either way, pause the video, show your substitutions, simplify, and solve. All right, so since I've only did it once using the ordered pair, I'll do that way again. So again, I want to write out my formula so that I can memorize it, or that you can memorize it. Y sub 1 plus k times y sub 2 minus y sub 1. And then you're going to substitute in. So here my x sub 1 is -2. My fractional distance is 1/4. 5 plus 2 for my x's. And then we would have -2 plus 1/4 times 7. I'll put 7 over 1 to make it into a fraction. So now I have -2 plus 7 over 4. And then I can combine those fractions using my calculator or saying I need a denominator of 4. So -2 I could rewrite as -8 over 4 plus 7 over 4 would give me -1 over 4. Pause the video and do the y coordinates. So for your y coordinates, we've got 0 plus 1/4, 8 minus 0, and you should simplify that from there, and your final answer should have been 2 for the y coordinate. So M has coordinates -1/4, 2. And you can always check that graphically as well. All right, next. Given segment A is 2, 4, and B is 5, 8. Find the coordinates of P on directed line segment AB that partitions AB in the ratio of 1 to 2. All right. See if you can do this one on your own. All right, so just to get an idea, if you are struggling, sometimes it helps to kind of see it here. So A is 2, 4, B is 5, 8, and we want to put P 1 to 2. So here's 1x, and this would be 2x. So if that's in a ratio of 1 to 2, K you should have as 1/3. So it's 1/3 from point A, 1/3 the distance along that segment from point A. All right, and then your formulas. So I'll do it the other way again. So not R, this is X sub P equals, and pause the video here if you haven't written this out on your own. You should really try to make sure you're memorizing the formulas and substituting in appropriately. Plus K, so we're adding the distance, the fractional distance from x sub 2 to x sub 1. Y sub P would be y1 plus the fractional distance along your y's. All right, and we substitute in, so x sub p, our x sub 1, and I'll label these up here, x1, y1, x sub 2, y sub 2. X sub 1 is 2, plus my fractional distance we said is 1/3. 5 minus 2. 2 plus 1/3 times 3. I can put that 3 over 1. These cancel. Even though they cancel, they don't completely go away. We're still left with a 1. So, and 2 plus 1 is 3. And then pause the video again if you haven't already. You should do this side on your own. This one does come out as a fraction. All right, and so our y sub p should end up being 16 over 3 for your final answer. So now our new coordinates of point P should be 3, 16 thirds. All right, and one more. R is a point located on segment or directed segment PQ such that, so I give it to you a little differently this time, PQ over segment RQ is equal to 10, excuse me, over 3. If P is the coordinates 10, 10, and Q has the coordinates 0, 4. Find the coordinates of R. So here we know, let's draw out a little segment here. So segment PQ, directed segment, R is a point such that PQ, if that's 10, so let's call that 10x. We don't know if it actually has a length of 10 because it could reduce to 10 thirds. And RQ, so R is somewhere along here, so that RQ is 3. Well, 3 is less than half of 10, so that means it must be closer to Q. So that means this must be 3x over here. So they gave us PQ is 10, RQ is 3, and it's reduced to 10 over 3, so we called it 10x and 3x, which means 10x minus 3x would leave us with 7x over here. So now you can tell your ratio or your distance. So I know that R then must be 7 out of 10. So it's 7/10 of the distance from point P along that segment. All right, if you haven't already, pause the video and find the coordinates of R. You will have a fraction in here as well. All right, so you guys should have all of that work shown. Your final answer should be 3, 29 over 5 for your final answer. Okay, and that is it. If you had any issues getting any of those, make sure you really know that formula. Please make sure you see me and ask if you need any help on these. All right, pie out.